Next, we will construct a most powerful test in the case of truncated exponential distribution. Okay, here the question is given a random sample of size n from truncated exponential distribution truncated at theta, construct most powerful test for testing h naught theta equal to theta naught versus h1 theta equal to theta 1, where theta 1 is less than theta naught. Okay, so here it's given that the sample size of n and also the from truncated exponential distribution where truncated theta, right? So what is the density of truncated exponential distribution truncated at theta? That is f of x theta equal to e to the power minus x minus theta, e to the power minus x minus theta, where we know that theta is greater than 0, right? Here it's a truncated at theta, right? Then x is greater than theta. Okay, the density of truncated exponential distribution truncated at theta is e power minus x theta, where x is greater than theta and theta is greater than 0. Okay, here is a problem says that the sample size of n, so we have to take the likelihood ratio, right? What's the likelihood then? If f of x theta equal to e power minus x minus theta, where x is greater than theta and theta is greater than 0, then what is the likelihood? L theta x equal to product of f of x theta, right? That is a e power minus summation I 1 to n xi minus theta, right? Where x is greater than theta, 0 otherwise, right? Here x takes the value in likelihood, x takes the value x1 x2 so on xn, nth order up to nth order statistic, right? First order statistic to nth order statistic. Then x takes the value here we can say that in truncated at theta x is greater than theta, right? But here it takes the value x1 x2 so on xn, right? Here in this case, so this x value is theta is must less than the first order statistic, the least value of this x. Okay, theta must less than greater than the theta must less than the first order statistic, that means the least value of xn. So we can write it as x1 is greater than theta. Okay, here x is greater than theta, which means in likelihood we can write theta must less than the least value of x. Okay, that is first order statistic, right? From Neyman-Pearson lemma we reject S0 for the large ratio, right? So in this case we have to take the ratio of likelihood under h1, likelihood under h0, right? Here under h0, what is the likelihood then? L theta naught x equal to here L theta x equal to e power minus summation I 1 to n xi minus theta, right? Where x1 is less than theta, but in the case under h0, here is theta naught and here theta naught, right? In the problem it's given that theta 1 is less than theta naught, right? So we have to write if this is the x values, x first order statistic values, then these theta 1, theta naught, infinite, right? This is the range. So here we have to write what is the value when x1 is between theta 1 and theta naught, right? If theta 1 less than x1 less than theta naught, then what is the likelihood under h naught? It's 0, right? Because here under h naught is become theta 1 is greater than theta naught, right? But here x1 is less than theta naught, right? So this value is 0. Then if theta naught less than x1 less than infinite, that is x1 is greater than theta naught, right? Then it's become likelihood become e power minus summation I 1 to n xi minus theta naught, right? 0 otherwise. Then what is the likelihood under h1? Under h1 L theta 1 x equal to, so first we have to write these limits. Okay, this if L1 less than x1 less than theta naught, if theta naught less than x1 less than infinite, otherwise. Okay, under h1 is take the value theta 1, right? Theta takes the value theta 1. Here if theta takes the value theta 1, then e power minus summation I1 to n xi minus theta 1 if x1 is greater than theta 1, right? So here theta 1, x1 is greater than theta 1, then let's take the value this, that is instead of x theta here theta 1, right? So here we can write e power minus summation I1 to n xi minus theta 1 here also, because theta 1 less than theta x1 is greater than theta naught, then let's take the value e power minus summation I1 to n xi minus theta 1, right? So in both these two limits of the same value, right? That is e power minus summation I1 to n xi minus theta 1, 0 otherwise, right? Then we have to take the ratio, right? That is likelihood under h1 divided by likelihood under h naught. So first we will write the limit, that is if theta 1 is less than x1 less than theta naught, if theta naught less than x1 less than infinite, otherwise. Okay, here theta 1 when if theta 1 less than x1 less than theta naught is value takes the value this one, right? But in h naught it's 0, then this ratio become 0 if theta 1 less than x1 less than theta naught, right? And here if theta naught less than x1 less than infinite, then here under h1 e power minus summation I1 to n xi minus theta 1 divided by this value, right? That is e power minus summation I1 to n xi minus theta 1 divided by e power minus summation I1 to n xi minus theta naught, right? 0 otherwise. And we will write these term as likelihood h1 likelihood under h naught equal to infinite if theta 1 less than x1 less than theta naught, x1 less than theta naught, then if theta naught less than x1 less than infinite, 0 otherwise. Here 0, right? In the second case, that is here we can write these term as e power, we can write these term as how we will write that, it is e power minus summation I1 to n xi minus theta 1. We can take these here, right? Then plus summation xi minus theta naught, right? Then these terms can get cancelled, then you can get e power minus, sorry, here minus into minus, right? Plus theta 1 here it's minus term, right? That is a minus theta naught, right? And you can write it here e power theta 1 minus theta naught, right? So here we reject H naught for the large ratio, right? Here we got one rejection region. Is the ratio is infinite, right? Because it's a rejection region, right? Because it's a maximum value of ratio, right? Then here we want to find out for which values take the maximum, right? So for that we have to draw a graph. Zero here it takes the ratio, that is a likelihood under h1, likelihood under h0. Infinite here this constant value, that is a e power theta 1 minus theta naught. Okay, e power minus here n, right? N into e power minus e power n into theta naught minus theta 1. Okay, here we will take in y-axis the ratio, right? And here x-axis is takes the value first order statistic, it is x1, theta 1 theta naught infinite. We know that theta 1 is less than theta naught, right? So we can write theta 0 theta 1 theta naught x. Okay, and in the ratio if theta 1 less than x1 less than theta naught, then it takes the value infinite, right? It is a here infinite takes the value infinite, right? From theta naught less than x1 less than infinite, then it takes the value as a constant, right? That is e power n theta 1 minus theta naught, right? So here here one, this is one of the rejection region, right? Theta 1 less than x1 less than theta naught, because it takes the value infinite, the maximum value, right? But here we have to find out for the which value it's a reject, right? It's a constant value, right? So we have to divide these as a k star and k. Okay, then that will get two rejection region, right? These rejection regions. First one, this is theta 1 less than x1 less than theta naught, and or theta naught less than x1 less than k star, right? And second one is theta 1 less than x1 less than theta naught, or k less than x1 less than infinite, right? Here also we got two test function, that is the first one is phi of x1. Okay, it is 1 if, so we will take first one as this rejection. Okay, it is k less than x1 less than infinite, or theta 1 less than x1 less than theta naught. 0 otherwise. And the second test function is phi star of x1 1 if theta naught less than x1 less than k star, or theta 1 less than x1 less than theta naught. 0 otherwise. These are the two test function, right? Then using this test function we have to obtain the size of the test and power of the test for the each test function. Okay, and also we have to find the value of k and k star. So we will go through the first one, that is phi of x1 1 if k less than x1 less than infinite, or theta 1 less than x1 less than theta naught. 0 otherwise. Okay, so we will find out the size of the test in the first case. size of the test. That is a expectation of phi of x1, right, is equal to alpha. So which implies from the test function phi of x1 we can write probability of under it's not k less than x1 less than infinite or theta 1 less than x1 less than theta not equal to alpha, right? So which implies p naught, we can write this term as p naught probability of k less than x1 less than infinite plus probability of theta 1 less than x1 less than theta not equal to alpha, right? Which implies here under h naught it takes the value 0, right? And h naught it takes the value 0, right? Then here remaining probability of k less than x1 less than infinite equal to alpha, right? Which implies integral over k to infinite f naught of x1 dx1 equal to alpha. Then what is the here is density of first order statistic, right? Then what is the first order statistic or density of first order statistic? So we have to find out the first order density of first order statistic, right? What is the formula for that? Density of first order statistic, that is f of x1 equal to n into 1 minus f of x equal to x1 power n minus 1 into f of x where x equal to x1, right? So here we know that what is a f of x, right? So here we want to find out what is a capital F of x, right? That is a f of x where x equal to x1 is equal to integral over how to find out that distribution, that is here in the case of what is this f of x here e power minus x minus theta, right? Where theta is greater than 0, x is greater than theta, right? So here we have to find out the distribution of x, right? That is it starts from the here x takes a value from theta, right? That is theta to x. Then density is e power minus x minus theta dx, right? Then integrate these terms, then we can write these terms as e power minus x into e power theta, same, right? Dx, you'll take e power theta is outside, theta to x e power minus x dx, which equal to e power theta integral over e power minus x is e power minus x divided by minus 1, right? Integral limits x theta, right? Then substitute the value, then you can get e power theta here e power minus x minus e power minus theta divided by minus 1, right? Which implies which equal to e power theta, then e power minus theta minus e power minus x, right? You can write this term as this type, then here e power theta divided by e power theta, right? That 1 minus e power theta divided by e power minus x, e power x, right? So we can write this as 1 minus e power minus x minus theta, but here x equal to x1, right? So we have to take here x1, okay? That is 1 minus e power minus x theta. Then what is the